Welcome back. It's great to still have you here in this project. And now that we have a good grip on the find method, let me introduce you to a close cousin of the find method, which is the find index method. And the find index method works almost the same way as find. But as the name says, find index returns the index of the found element and not the element itself. So let's see a great use case for find index in our application here, which is the close account feature that we have here. And in our application here, closing an account means to basically just delete that account object from the accounts array. So from this one here. Okay, so for example, if Sarah decides to close her account, then this account 4 will simply be deleted, and that's it. Now, to delete an element from an array, we use the splice method, remember? But for the splice method, we need the index at which we want to delete. And where could that index come from? And you guessed it, from the find index method. So let's first select this button here and attach an event handler to it. And so that's the button close here. So let's come down here to our event handlers. Now we have multiple. And button close dot add event listener, click. And then as always, our function in which we need the event object so that we can call prevent default. All right, let's just test if this connection works here. Let's log in. And now as we click this here, we get delete. So that's great. And now let's take a look at our flowchart here. And so, yeah, the first thing that we need to do is to check if the credentials are correct. So basically, if the username that is inputted here is equal to the current user and the same for the PIN. So that doesn't sound too hard, does it? So actually, let me leave that for you as a challenge. So just write this condition here to, again, check if both the user is correct and the PIN. All right, I hope you did that. So let's first take a look at the element names that we have up here. And so that's input close username and input close PIN. So I hope you figured these names out here too. And so let's now say input close username dot value needs to be exactly the same as the username in the current account. So current account dot username. So this needs to be true, and the same thing for the PIN. So that's input close PIN dot value, and once again convert it to a real number. And this one also needs to be equal to the current account dot PIN. And now let's actually do the deletion itself here. So as I already said, we are going to use the splice method to delete the current account. So let me actually start by writing that part. So we will take our accounts array and splice it at a certain index, which is the index that we're going to calculate in a second, and we will remove exactly one element. All right, and then the splice method actually mutates the underlying array itself, and so there's no need to save the result of this anywhere. All right, and so now let's actually calculate that index at which we want to delete. So we take the accounts, and now instead of find, we use find index. And once again, this one takes a callback function, which is very similar to all the other callback functions we have been using. So it's going to loop over the array essentially, and in each iteration we get access to the current account, and then we want to find the one where the account has the username equal to the current account dot username. All right, and so let's then take a look at that index. And for now, let's actually take out this part. Okay. And we will then come back and maybe explain this a little bit better. So as I click this here without anything, nothing happens. So just as we intended. Then with the correct user and with a wrong pin, also nothing happens. And notice that here you cannot see the numbers I'm typing now because this is a different format in HTML, but I'm still using the 4 ones. So 1, 1, 1, 1, and now something should happen. And indeed, we get the index number of the JS account in the accounts array. So let's take a look at that array here. And indeed, the Jonas one is number 0. Right? Now, if we logged in here as Steven, STW with 3333, and now we need to confirm that here. So STW again and 3333, hit enter, and then the result should be down here, and indeed it is. So that's element number 2. So 0, 1, and 2. So that is correct. And so our splice here would now indeed delete the user. Okay, so let's see here what we did in the find index. So just like before in find, we passed in a condition, so something that will return either true or false. And the find index method will then return the index of the first element in the array that matches this condition. So for which this condition here returns true. So again, similar to find, but it returns the index and not the element itself. Now you might notice that this is actually similar to the index of method that we studied before. So index of, and then here we can pass in some value. All right. Now the big difference here is that with index of, we can only search for a value that is in the array. So if the array contains a 23, then it's true, and if not, then it's false. But on the other hand, with find index, we can create a complex condition like this one. And of course, it doesn't have to be the equality operator here. It can be anything that returns true or false. Okay, and here we can simply check if the array contains this value or not, and if so, return the index of it. So both return an index number, but this one here is a lot simpler. And so now let's actually delete this element here. So this current user, or the current account. And now let's get back here to our flowchart, which I closed for some reason. And so we just did this part. Now we also need to log out the user. So that just means to hide the UI. And so that's similar to what we did here, where we showed the UI. Now we want to set it back to 0. So down here. So hide UI, and here delete account. Okay, and then of course, as we reload the page, as I said before, the user will then be back, of course, because we do not persist this data anywhere. All right. Well, the UI is still there. Oh, and that's because we didn't change this here to 0. But anyway, let's still take a look at the accounts object in this moment. And we see that we now only have 3 accounts left. And the one of Jonas is nowhere to be found. So this means that it actually worked. Now we just need to fix this here and set it to 0. And we also, just like before, want to clear these fields here. So that's the same as we did before. So similar to this one. Let me just copy it here. And this one we can paste right here outside of the if statement. And then just copy these two inputs here. So close username and close pin. This is set to 0. And now this should actually be complete. So let's see. Well, nothing happened. So let's see here. Oh, okay. This is a bug that I just introduced here. So basically, before even reading the data from this field, I'm already setting it back to empty here. Okay, and so therefore, of course, nothing can work. So this needs to be after the if-else statement. All right, but it's still a good thing that these small bugs keep happening here so that I can fix them and show to you that everyone makes this kind of mistakes. So let's try it again, 1, 1, 1, 1. And now it's gone. And as I try to log in now as this user, you see that nothing happens, and we get undefined down here. And that's because this user no longer exists now in our accounts array. Great. So one more feature implemented successfully. Now, there's just a couple of things I want you to note here. Both the find and find index methods get access to also the current index and the current entire array. So as always, besides the current element, these other two values are also available, but in practice, I never found these useful. And second, both the find and find index methods were added to JavaScript in ES6, and so they will not work in like super old browsers. But don't worry, there is going to be a lecture a little bit later on how to support all of these old browsers. So we're getting closer to the end of this section, but there are still a couple of array methods left to learn. And so in this lecture, we're going to look at the sum and the every methods. And to start learning about the sum method, let's look back at the includes method that we studied earlier. So let's log to the console here, movements.includes minus 130. And let's also log our movements array so we can see it. And so indeed, the value of minus 130 that we're testing here is in the array, and that's why we get true here. And so we can use the includes method to test if an array includes a certain value. Now, however, we can only really test for equality, right? So basically, includes here returns true if any value in the array is exactly equal to minus 130, right? And so, again, this is essentially testing for equality. But what if we wanted to test for a condition instead? And so that's where the sum method comes into play. So let's say that we would like to know if there has been any deposits on this account. So in other words, we want to know if there is any positive movement in this array. So any number above 0. So how would we do that? Well, we can say movements.sum, and now we can specify our condition here as always. So the same callback function, which has to return either true or false. And so a deposit is a movement greater than 0. So let's call this here any deposits and log it to console. And so indeed here we get true. So we have, of course, more than just one deposits here. But let's say we wanted to test if there is any deposit above 5,000. So easy enough, we can check if there is something above this value, and then it is false. Or we can check if there is something above 1500, and so now it's true, because there is one movement here in that condition. And so you can see that these two methods here are kind of similar. The difference is that here it checks only for equality. So equality, but here we can specify a condition. All right. So basically this one here, we could rewrite it like this. So let's log it to the console here. So movements dot sum minus 130. So this would be exactly the same. And so that's why we also get true in this one. Now for equality, this doesn't make much sense. We could then simply use the includes method. But for the case we need a condition like this one here, or really this one, then the sum method is perfect for that. Okay? And probably if I would have named this method, I would have called it like any. But of course, that's not the real name, but that's really what it does. If there is any value for which this condition is true, then the sum method will return true. All right. And now let's actually use this sum method to implement our missing functionality, which is to request a loan to the bank. So we will do that right here between the transfer button and the close button. And the sum method will become helpful for this loan feature because our bank has a rule which says that it only grants a loan if there is at least one deposit with at least 10% of the requested loan amount. So that sounds complicated, but we will implement this here in a second. So button loan, add event listener, click, and this is now always the same as you can see. So starting by preventing the default action. So that's always going to be the first thing. And then let's take a look here at the user interface, because right now it is hidden. So you see that here we only have this one field. This field is called the input loan amount. Okay, so input loan amount. So that's the element with this long class name. So let's copy that actually. And so let's start by actually getting that amount here. So we already know we will have to convert this input dot value. Okay. And now we need to create our condition here. So first of all, that amount should be greater than 0. Okay. And now let's take a look here at our flowchart again. So this is what I was saying earlier. The loan is only granted if there is any deposit that's greater or equal 10% of the requested amount of loan. All right. So here we need now our second condition, which translates that. And so whenever we see or hear the word any, we can already know that it's probably a good use case for the sum method. So let me show it to you. So as always, we get the movements from the current account object dot movements, and now on there we call the sum method. So you already know by now how this callback function feature here works. So we get the current movement in the current iteration. And now here the condition is that movement needs to be greater or equal than 10% of the amount. So that's the amount divided by 10. Okay. Or we could also do times 0.1, and so that's exactly the same thing. So 0.1 here stands for 10%, and so let's keep it like this. Give it a save so that it looks nicer. And so, yeah, if at least one of the elements in the movements array has this condition, so is true, so basically is greater than 10% of the requested amount, then all of this here will become true. And so the sum method is perfect to be used in a condition like this. So when we need to test for something. Okay, so in case this is true, oh, and I closed our flowchart again. So in case this is true, then add a positive movement to the current data and update the UI. So that's easy enough. So add the movement here. So current account dot movements dot push, and then of course the amount that was requested. And then update the UI. And for that we already created our nice function which does all of the functionalities in one go. And so that's update UI, and we simply pass the current account into it. Okay, and that's it. Finally, let's also then clear the input field. So that value equals empty value. So we did that here and also up here. Okay, let's log in. And so you see my deposits, my largest deposit is 3,000. And so the loan that I can request can be maximum 30,000. Okay, because 3,000 here is 10% of that. So let me try something bigger, so something really huge. And so now nothing happened. And again, in the real world, we would then probably get some error message somewhere here at the top or so. But in this case, we're not going to do that. Let's just try 5,000 now. And so now, indeed, it appeared here in our movements. And also, as you see, our balance was updated. And also here, our total income. Okay, now let's request 50,000. And so with this, you can now actually cheat. You can always create a little bit of a larger number. So now I can even request 500,000. And so that's cheating our algorithm, which is way too simple. But of course, this is just for testing purposes. All right. So that's how the sum method works. I hope that makes sense. And so let's now actually go back here and talk about the close cousin of the sum method, which is the every method. So let's write here sum and every. So again, the every method is pretty similar to the sum method, but as you might guess, the difference between them is that every only returns true if all of the elements in the array satisfy the condition that we passed in. So in other words, if every element passes the test in our callback function, only then the every method returns true. And that's why the method is called every in the first place. So let's test it out here now. So let's log to the console movements.every, and then with the same condition. So let's essentially check if all of our movements here are deposits. And well, indeed, they are not, and that's why we get false. However, we do have one account which only has positive movements. So let me show that to you. That's account 4. So account 4, all the movements are positive. So let's check it out now. So count 4, and then the same condition. And every is not a function. And that's of course because we are still missing the movements array. And now it is true. All right. And so that indeed proves that the every returns true if all the elements in the array satisfy this condition. Because in this movements array, all of the values are in fact above 0. Okay. So that's how the every method works. And I think it's quite straightforward, isn't it? And now to finish, there is one more cool thing that I want to show you. So up until this point, we have always written the callback function directly as an argument into our array methods, right? However, we could also write this function separately and then pass the function as a callback. So let's say separate callback. And so we could do this. So let's call the posit to this function. All right. And so this function here is exactly the same as these ones. But as I just said, there is no reason for them to being directly written here in all of these array methods. We could simply write them like this, and then all we would have to do is to call movements.sum, for example, and then deposits or deposit. And now we could reuse the same function for all kinds of different methods that require callbacks with a true-false condition. So that could be every or filter as well. Okay. And so here is the result of these 3 operations. And so here we get the expected results. And all by reusing this same function. Then if we wanted to change the function, all we would have to do is to change it here in one place. And then all the results would become different according to that. So in practice, that's something that we do sometimes, because this is of course better for the dry principle. So don't repeat yourself. That's always important, and it is important here as well. But anyway, with this small detour that we did here, let's now move on to learning about 2 more array methods. The next 2 array methods that we're going to learn are the flat and flat map methods. And thankfully, these are very easy to understand. So let's go. So let's say that we have an array with some arrays in it. So essentially a nested array. So let's say 1, 2, 3, and then another array here, 4, 5, 6, and then even some values like this. So this is perfectly normal. But what if we wanted to take all these elements in the subarray and put all of these together in just one big array, which contains all the numbers here from 1 to 8? Well, that's pretty simple using the new flat method. And they say new because flat and also flat map were introduced in ES 2019. So they are pretty recent. And one more time, they will therefore not work in super old browsers. Okay, and actually that's it for the flat method. So no callback function, just like this. And we get indeed our full array from 1 to 8. So this removed the nested arrays and flattened the array, which is why the method is called flat. So very nice, very simple, and no callback function this time. Okay, but now let's say that we have an array which is even deeper nested. So let's call it R deep. And so this one right now has only like one level of nesting. But let's say that these 2 here are in their own array still. And maybe these 2 here as well. So now we have an array inside an array inside an array. So let's see what happens when we flat this one. And we got the same result, but that's because I made this mistake. So we need to flatten error deep. And so now you see that we get this result, which still contains the two inner arrays. All right. So this means that the flat method only goes one level deep when flattening the array. So this 3 here was inside the first level of nesting, and so therefore it was taken out and is now in the main array, but then we still have this nested array in there. So we can fortunately fix that by using the def argument. So right now, basically flat is running with the 1 here as the def. And so if we run it with 1, which is the default, then we get this, but we can go 2 levels deep. And so now we get the same result as before. And that's because it now goes even into the second level of nesting and also takes the element out of that array. All right. So that's how flat works, but this example is not really that useful. And so let's go back to the bank accounts. So let's say that the bank itself wants to calculate the overall balance of all the movements of all the accounts. So how would we go about solving this problem? Well, first of all, we have all these movements stored in arrays. And these arrays are inside the objects in the accounts array, right? So in this array that we have been using, so accounts, so that's the one. So this is where we have our movements. And so the first thing to do is to take them out of here and put them all into one array. So how would we do that? Well, let's create a variable here called account movements. And so we could do accounts like this. And then what we want to create is a new array, but with the same length, which only contains these movements array. So that's what I was just saying, right? And so for that, we can use the map method. So in each account, take the account dot movements and so return that value into the new array. All right. And so now we have this array, which then in turn contains the arrays of all the movements. And so you see that now we actually have a nested structure here. So an array which contains other arrays. And so probably you can see where I'm going with this, because now I want an array which simply contains all of these values just in one array. So let's call this one all movements. And so it's going to be account movements dot flat, right? And we have only one level of nesting, and so there's not even a need for any parameter here, so for any argument. So now we get this nice array of the length 29 with all of these movements. And now all we have to do is to add them all together, which is pretty easy at this point, right? So let's call this one overall balance is equal to all movements dot reduce. And here we get the accumulator and the current movement. And we return accumulator plus movement, and we start with 0. So I'm doing this all very fast here because I already explained all of this multiple times at this point, right? And so here we get the final result of adding up all of these values that were originally, as we started, in the separate movements arrays that were in turn inside of the account objects, right? And of course we can make this here a lot more beautiful. So instead of doing all of this separately, as you already know, we can use chaining. So we start with this here. So building a new array out of the array of account objects. Then we flat that result, and then we add it all together. So like this. And then we log it all to the console. And this is then unnecessary. And actually, I will just delete all of it. Give it a save. And here we get the exact same result. Now, it turns out that using a map first and then flattening the result is a pretty common operation. So that's exactly what we have here. So first we map and then we flat that result. So that's exactly what we have here. And so to solve this, there is another method that was also introduced at the same time, which is flat map. And so flat map essentially combines a map and a flat method into just one method, which is better for performance. All right. So let's do this one here again, but this time with flat map. So actually we can just copy it, and here I'm going to call it just a 2. And so here we will now use flat map instead. And since flat map also does mapping, it needs to receive exactly the same callback as a map method. Okay, so this is essentially a map method. All it does is, in the end, it then flattens the result. And so you see here the result is the same. Now just notice that flat map here only goes one level deep, and we cannot change it. So if you do need to go deeper than just one level, you still need to use the flat method. So anyway, keep these two in mind whenever you find yourself in a situation where you have nested arrays and need to work with them. And believe me, that happens more often than you think. And I believe that even in the course of this course, there is going to be another situation. So we're almost finished with this section and with our application. But one feature that is still missing in our application is the ability to sort or movements. And so in this lecture, let's talk about sorting arrays. Now, sorting is a much discussed topic in computer science, and there are countless algorithms and methods of sorting values. And we might actually talk about this a little bit later in the course. For now, though, we're simply going to use JavaScript's built-in sort method. And let's start here with an array of strings. And let's call it owners. So Jonas, Zach, Adam, and Martha. Okay. And now all we need to do is owners dot sort. Okay. And so indeed, we now get our array here nicely sorted. So alphabetically from A to Z. So this works indeed just as expected, right? Now this actually mutates the original array. So if we take a look at owners now, you will see that it also is now mutated. Okay, and so we have to be very careful with this method. So this is with strings. Now let's try it with numbers as well. So let's use our movements array here one more time. So I will start by logging it to the console so we can see it. And then let's also log movements dot sort. So give it some more space here. And if we take a look at the result here, this time the result is not really what we are expecting, right? These numbers are not at all ordered in any way, are they? And the reason for this is that the sort method does the sorting based on strings, all right? So that might sound weird, but that is just how it works by default. So basically what it does is to convert everything to strings, and then it does the sorting itself. And if we look at the result as if they were strings, then the result actually makes sense. So the minus here, you see, always comes first. Okay, so first you have all the minuses here, and so that's basically alphabetically the first string that occurs. And then afterwards, you have this one which starts with 1, before this 4, and then before this 6. So these three are alphabetically ordered if they were strings. And the same here. So you have 1 first, then 2, then 3, then 4, and then 7. So again, if they were strings, then this result would make sense. But they are not strings, and so we have to fix this. And in fact, we can fix this by passing in a compare callback function into the sort method. So this here does not work. Let's get rid of it. And so let's write movements.sort, and we need to give it a callback function. And this callback function is called with 2 arguments. And let's simply call them A and B. Okay. And these 2 parameters here are essentially the current value and the next value if we imagine the sort method looping over the array. However, in order to understand how the compare function works, so how this callback function here works and how we have to write it, let's just think of A and B as simply being 2 consecutive numbers in the array. And it doesn't matter which ones. So let's simply take these 2. So 450 and 400. Okay? So let's just compare these 2. Now, in our callback function here, if we return less than 0, then the value A will be sorted before value B. And the opposite, if we return a positive value, then A will be put before B in the sorted output array. Okay, so let's use that in practice to sort the movements array in ascending order. And first, let me just write what I just did here. So if we return something less than 0, then A will be before B. But on the other hand, if we return greater than 0, then B will be before A. Okay? And so we can use this knowledge to sort our movements array now in an ascending order. So ascending order means that we want to go from small to large numbers, right? And to make this easier to understand, let's analyze the 2 numbers that we have here. So we have 450 and minus 400. And so if we want to sort these 2 in an ascending order, then we need to switch them. So this is A and this is B, right? But now we want to switch them to make them in an ascending order. So what we want here is B and then A. So BA, right? And so therefore we need to return something that is greater than 0. Okay, because that's the rule how the sort callback function works. So again, in the case basically that A is greater than B, which is what we have here, then we want to return something that is greater than 0. So let's write that. So if A is greater than B, return, and let's say 1. And the number here doesn't really matter as long as it's greater than 0. And else, or actually let's write it like this. So if B is greater than A, then return something negative. So just minus 1. Okay, and that's actually it. So let's log then the movements again here to the console, because here we are mutating the array, and then at this point it is already the mutated version. And now, as we see here, the array is now indeed sorted in an ascending order. All right, and so that is because basically the sort method keeps looping over the array and applying this callback function here until everything is in an ascending order according to the rules that we established here. Okay, so returning 1 here basically means to switch the order, and let's write that here. switch order, and keep order. So maybe that makes it also a bit easier to understand. So if we come back to one of these examples here, so let's say we have A and B 200 and 450. So in this case, we want to keep the order, right? And so therefore, that's the case in which we return something less than 0. So that's what we have here. And maybe it's easier to read like this. So A less than B, but of course it's the exact same thing. And then here again with our original example, this first one is greater, so the order has to be switched. And so here we have that situation where A is greater than B. Now, if we wanted to do it the opposite, so sorting in a descending order, we would simply do it exactly the other way around. So all we would do is to return -1 in this case and return 1 in this case. And so now the array is nicely sorted the other way around. So let's write that here. So ascending and descending. Let's also log the movements here. And great. So this works beautifully. And it's also going to work for strings. And you can try that out yourself if you want. Now, if we are working with numbers, then we can actually simplify this a lot by simply using some simple math. So let's take a look again here at our condition. So we already know that if A is greater than B, then A minus B would always be something positive, right? And the same here with A less than B. So if A is less than B, then we know that A minus B is always something negative. And something negative is exactly what we want to return here, isn't it? And so what we can do is take this and improve it dramatically. Because in fact, we don't need any of this. All we need is to say A minus B. And that's it. Let's check the result. And it still works the same. So let's recap what we did here. So again, we already know that if A is greater than B, then this will be a positive number. And so here we then return that positive number. It doesn't have to be exactly 1, just something greater than 0. Now, if it's the other way around, if A is less than B, then this operation will always be a negative number. And so therefore, then something negative is returned just as -1. But again, it can be any number. And by the way, if we return 0 here, so in case these two values are the same, then their position simply remains unchanged. All right? So let's do the same here. And so here it is the opposite. So B minus A. And as always, keep in mind that we are actually returning this value here. But we don't have to write the return because we're using an arrow function. So you see, it still works the same. All right. And this is basically most of what you need to know about sorting arrays with numbers. Now, if you have a mixed array, like with strings and numbers together, then this is not going to work. And I advise you to simply not use the sort method in these cases anyway. And that's because there's not really a point in doing so. But anyway, now that you know how the sort method works, let's go back to our application and implement it there. So let's first see in the demo version what I mean. So down here we have this sort button. And so this sort will basically sort these movements. So as we click the button, it will sort them in this descending order, which actually is an ascending order because remember, we are starting to display these movements here from the bottom up. Okay. Then as we click it again, it goes back to normal. So as we keep clicking, it orders and goes back to normal. And so let's implement that now. So we can give us some more space here. And now we will actually implement the sorting functionality right in the function that displays the movements. Okay, so let's first implement the sorting itself, and then after that we will implement the clicking on the button. So that's right here. So display movements. All right. Now what we're going to do here is to add a second parameter, which is the sort parameter, and by default we will set it to false. And now depending on this parameter, whether it is true or false, we will then order our movements or not. So sort the movements or not. And of course it is false by default because, well, by default we do want to show the movements just in the order they appear in the array. But then as we click that sort button, we will then call this function display movements with sort set to true. So let's now create a new variable called movements here. And this variable here, we will define it conditionally. And actually we cannot call it movements because that's already the name here of the parameters, right? So let's just call it movs, all right? And again, we will define it conditionally. So we say if sort, and so that's if sort is true, then we actually want to sort the movements. So the movements array that we get here as an input. So movements, but now we cannot do this. And that's because, keep in mind that the sort method will then order the actual underlying array. So the actual movements array as it is in the account object. But that's not what we want at all. All we want is to display a sorted movements array, but we do not want to sort the original underlying data. So what do we do here? Well, we simply take a copy of the movements array and sort that. And so that's what we use now slice for. And this is one of the situations that I was telling you about earlier, where we need to actually create a copy using the slice method and not the spread operator. Because here we are in the middle of a chain. And so we want to keep going after this. And so it's a lot better to simply use the method here so that we can then simply chain the sort method onto that. And now all we need here is our compare function. And now remember how in the user interface, so in our application, how the movements appeared in a descending order. However, that is because we start to display the values from the bottom up. And so actually we want to now sort this array in an ascending order. And to do that, remember we do A minus B. So I explained before why it works this way. Okay, but now if sort is false, so that's the default value, then movs should simply become movements. Right? Let's get rid of this comment here. Give it a save. And now here, of course, we then need to use that movs that we just created. And with this, we have essentially adapted our display movements function to support sorting. And again, we did that by allowing a second parameter, which is an optional parameter called sort. And then if sort is set to true, then the movements that we're going to use to display them will be sorted like this. And if it's set to false, then simply the regular movements as they are passed in will be displayed. And now all we need to do is to call this function here with sort set to true whenever the user clicks that sort button. So that button is called button sort. And so let's now create our final event listener or event handler here. So button sort add event listener, And as always, we start by preventing the default, so you can get used to this. And then here we want to call print. And then here we want to call display movements. And of course with current account dot movements as always. And then the second parameter we will set to true. So that's the sort parameter. And if we ever are in doubt, again in VS Code, it nicely shows us what we can pass into the function. So movements and sort. Now this is not yet the 100% working solution, and let me show you why. So, as I log in, let me almost remove this here. So let's click now the sort button, and beautiful, that worked. So the movements are now indeed sorted, but now if I click the button again, it will not go back to normal, right? And how could it? We never told it to do so. So let's find a way of solving this. And we will solve this by using a state variable which will monitor if we are currently sorting the array or not. Okay, so that variable needs to live outside of this callback function so that its value can be preserved after clicking this button here, right? Because as you know, this function here is executed each time that we click the sort button. And so if we defined a variable here in this function, then it would be created newly each time that we click that button. And so we want to preserve that sorted state throughout all the clicks. So we start with this state variable set to false. And so that's because in the beginning our array is not sorted. So sorted is false. And so if it is false, then here this should be true. So we then want to actually sort the array. So basically here we want the opposite of sorted, right? And so that's where our not operator comes in handy. All right, so we're doing the opposite of sorted. When sorted is false, then we want to sort it. So we need true here. But if it is already sorted, then we again want the opposite, and so then sort should be back to false. Now the only thing that's missing is to actually flip this variable. Okay, and so for that we do sorted equal the opposite of sorted once again. And so this is what then allows everything here to work. Otherwise, even as we would click, this sorted variable would then never change. And so with this, each time that we click, we change sorted from true to false, then from false to true, and so on and so forth. So let's try it now, finally. And yes, great, that works beautifully. And so our job here is done. And in fact, this application is now complete, at least for this section. So great job, congratulations for reaching this point, for finishing this application. This is really an amazing achievement, and you can pat yourself on the back for making it this far. Now, there is still 1 or 2 array methods to learn, and so let's do that in the next video. The last thing that we're going to learn in this section is how to programmatically create and fill arrays. So far, we have always simply created arrays like this, right? So basically writing them out by hand, literally. So just like this, or maybe we might have done it also like this. So using a new and then the array constructor, and then passing in all the numbers here as arguments, and then that also creates this array, right? Now in these cases, we basically already have our data. So for example, 1, 2, 3, 4, all the way to 7. So that's the data that we already have. And so therefore, we could then manually create these arrays. However, we can actually also generate arrays programmatically, so without having to define all the items manually. And there are many situations in which this is necessary, and there are also multiple ways of doing it. And the easiest one is to, again, use the array constructor function. So let's create a new array here, like this. And then I will pass in only one argument, 7. So what do you think is going to happen? Well, we might think that this is going to create an array with only one element, number 7, right? But actually it doesn't. Instead, it creates a new array with 7 empty elements in there. And it simply contains nothing. So this output is very weird indeed. And the reason for that is this weird behavior of this array function, which does it so that whenever we only pass in one argument, then it creates a new empty argument with that length. So if we don't know about this special particularity of the array constructor function, then this can lead to weird errors. Okay. Now, also, we cannot really use this X array for anything. For example, we cannot call the map method on it to now fill it up. For example, we might want to do this. So map, and then in each element, we might simply want to put something there, like a 5. But then you will see, well, actually we need to log it to the console. But you will see that nothing happened here. So this is not really useful except for one thing, because there is one method that we can call on this empty array, and that is the fill method. So that's a new method that we haven't studied yet, but it's very straightforward. So let me show it to you. So that's x.fill, and then all we need to do is to pass in a value, and it will then fill up the entire array with this specific value. Okay? And this does actually mutate the underlying array. So we can just change it there, and then simply log the entire thing to the console here. So this doesn't work. Let's take it out. And now we get this array full of 1s. But let's actually turn this off so we can experiment a little bit more with fill, because this method is actually a little bit similar to the slice method. So besides this value that we want to fill the array with, we can also specify where we want it to start to fill. So let's say only at index 3. And so we also can specify a begin parameter, and then it only starts at index 3, which is this one. So it will then fill it up until the end, unless we specify an end parameter, just like in slice. So let's say 5. And also, just like in a slice, the final index here is not going to be included in the array. So just these two here are filled up. And of course, we can also use the fill method on other arrays. So it doesn't have to be an empty array. Let's say we actually define this here as an array. Okay. And then we can also fill that array. So let's say r.fill. Let's fill it with 23 at position 4 to 6. And again, it will mutate the original one. And so you see that we put these 23s in these two positions. So from 4 to 6. Let's say from 2 to 6 to put some more in there. Okay? So this is the fill method plus empty arrays. So empty arrays plus fill method. And with this, we created an array programmatically, so without actually having to write it down manually, right? So let's bring this part back also to see it. So it's an entire new array that we here just created with our code. And indeed, the fill method can be very useful sometimes. However, what if we actually wanted to recreate the array from our first example? So what if we wanted to create this R array programmatically? Well, for that, we could use the array.from function. So that's array.from. And this is how we use it. And this is actually something completely new. And we didn't see this before. So here we are not using the from here as a method on an array. Okay? Instead, we are using it on the array constructor. So that's why it's array.from. And this array here is exactly the same as this one. So this function. So again, array here is a function. And then on this function object, we call the from method. So that sounds confusing, but we will make more sense of it in the object-oriented programming section. But anyway, into this function here, we can first pass in an object with the length property. So let's set it to 7. And then the second argument is a mapping function. So it is exactly like the callback function that we pass into the map method. So to start, let's also programmatically recreate this array here of 7 ones. And so let's write a callback function here. And in this case, we don't even need any arguments, but we still have to write the function. So let's write an arrow function here, which will simply return 1 in each iteration. So no arguments, no current element, no current index, and nothing. So all we want to return is a 1, and that will then put a 1 in each of the array positions. So let's call this one here y, and then log it to the console. And indeed, we get here the exact same result that we had before. But in my opinion, this is a lot cleaner than using this weird new array behavior then and together with the fill method. So in my opinion, this is way nicer. But anyway, let's now take it one step further and actually create this initial array from 1 to 7. So array.from length equals 7, and then our callback function. And as always, we get access to the current element. So let's call it current first, and then the current index. And so the index will vary between 0 and 6. And so all we have to return from this function is I plus 1. Okay? So again, this callback function here is exactly like the one in a map method. So you can simply imagine that you're using this as a callback function in calling the map method on an empty array. Okay? And so as always, we get access to the current element and the index. And so adding 1 to the index will then give us values from 1 to 7. So z meant yeah, here we go. Now remember how earlier I used a variable like this, so an underscore, which means a throwaway variable. And so this is another use case for using this convention, because we do not need this current value at all. But we still, of course, have to define something as the first parameter, because the index that we need is only the second parameter. But to denote that we are not using this current element, we simply write an underscore. Okay, and then other programmers will also understand this convention and automatically know that we don't use this parameter. Okay, so this is how we create an array programmatically, and I hope you can see all kinds of different use cases for this. For example, you could create an array with 100 random dice rolls. So maybe you want to try that out on your own, and that is actually one of the assignments that I have later here for this section. So there's going to be a couple of exercises, and this will be one of them. But you can try it out immediately if you feel like it. So try array.from to generate an array with 100 random dice rolls. Okay, see if you can do that. But anyway, let's now move on and see a more real use case of the array.from function. Now, this array.from function was initially introduced into JavaScript in order to create arrays from array-like structures. So remember how I talked about so-called iterables before? So things like strings, maps, or sets, they are all iterables in JavaScript. And so they can be converted to real arrays using array.from. Okay? And that's the reason also for the name of the function, because we can create arrays from other things. All right? Now, besides these obvious iterables that I just mentioned, like maps or sets, another great example of an array-like structure is the result of using query selector all. So maybe you remember that query selector all returns something called a node list, which is something like an array which contains all the selected elements. But it's not a real array, and so it doesn't have methods like map, for example. But it's not a real array, and so it doesn't have most of the array methods like map or reduce. So if we actually wanted to use a real array method like that on a node list, we would first need to convert the node list to an array. And for that, array.from is perfect. So let's do something here now. And let's say that we do not have the movements of our application here stored in an array. So let me show that real quick. So again, let's pretend that we only have these values, so all of these movements, only stored here in the user interface, but we do not have them somewhere in our code. So we don't have an array containing these values. But now, let's say we want to calculate their sum. And so therefore, we need to somehow get them first from the user interface and then do the calculation based on that. So let's create a variable called movements UI. So the ones that we get from the user interface. So array.from, and now here the element that we want to convert to an array. And so that's going to be document.querySelector all, and then it is the movements value class. I'm going to show it to you in a second. So movements value. So in our HTML, we can see that exactly this is where the value itself is stored. And so that's what we want to get. So these numbers, right? And so we are selecting all of the elements that have this class. All right. So let's just start by checking it out. Movements UI. But now we only get 2 elements here. And so that's the one that by the time we load this script here are already in the user interface. So it's this and this one here. So not the 7 that are loaded from the account object. So it's not going to be these 7 here. Okay. So if we wanted to actually select exactly these elements, we would have to do this code here on some event handler. So let's do that actually. Let's simply perform this action when we click somewhere here. Let's say here on this balance label. So it doesn't matter where we click. So that is called the label balance. So we can attach event listeners to every object. Okay, it doesn't have to be a button. So I think we never did this actually. But let's see what happens now. So let's log in again here. And again, remember that we are doing this so that we can now read these 7 movements from the user interface as we click here. And indeed, now it worked. So now we get these 8 movements here. And you see that indeed it is these values that we see now on the screen. All right. But now let me also show you that we cannot call the map method on it, because the map method would be useful to now actually get just the number. Because you see that here we also have this euro sign, and so we need to get rid of that. And so the map method would be perfect for that. So what we would like to do is, let's just do it here for now. We would love to take the current movement. All right. And so in this case, the movement here, well, let's just call it element actually, because right now it is a DOM element. So we would take this movement, which is, remember, one of these elements here. And so from this element, we need to take the text content. And then we also want to replace the euro sign with nothing, basically. So I'm using the emoji picker here again on the Mac, but you can just get the symbol from your text up there, so from the code we already wrote. And I want to replace it with nothing. But now you will see, as we try this again, that it's not going to work. And in fact, it does actually work. And that's because I was saying it wrong. Of course it's going to work, because this one here is already a real array at this point. So we created this movements UI using array.from. And so of course it is going to work already. It would not work if we did it directly on the result of the query selector all. Okay? So sorry for that mistake. So it did indeed work already. But we can make this even better. First, of course, we need to convert this to a number. But that is not the point here, actually. So the point is that we can use now the second argument of the array from a function here, which is, remember, the mapping callback. And so basically, we can simply put this entire callback right here as the second argument. Okay, and now this movement UI array is already the final array as we see it here. So let's just check that out and then make really clear what just happened here. So again, and as we click here, we get indeed all the numbers that we have here. So let's recap. We used array.from to create an array from the result of the query selector all, which is a node list, which is not really an array, but an array-like structure. And that array-like structure can easily be converted to an array using array.from. And then as a second step, we even included a mapping function, which then transforms that initial array to an array exactly as we want it. So basically converting the raw element to its text content and replacing the euro sign with nothing. Okay, and so then in the end, we end up exactly with the array of numbers that we intended. And by the way, I'm not sure if I mentioned it earlier, but there is another way of converting this here to an array. So let me grab it here. So movements UI2, and then we can actually spread the result of this query selector all into a new array as well. So this also creates the array, but then we would have to do the mapping separately. And so actually I prefer this. So to me, the array.from function was a great addition to JavaScript in ES6. Okay, and that's actually all I had to tell you here in this video. So that was the last couple of methods and functions that we learned about arrays. And indeed, we learned a lot of methods in this section, right? Now, keeping all of them in your mind to solve different tasks is, of course, a very hard thing to do. And so to make sense of all this mess, in the next video, I will help you decide which array method you should use in each situation to solve different problems.